Right. Howdy. How are we? I'm looking at question 13. This is in exercise 7b on page 191. And we want to look at this question here, 13. We've got a hat and it contains 2 red balls and 2 green balls. So there we go, there's my hat. You can't see inside the hat. There's 2 red balls, 2 green balls, and we want to draw balls out of the hat. It says balls are selected, right? That means they're pulled out of the hat without replacement. So once you take a ball out, you don't put it back in until a green ball is selected, okay? So you could imagine that you would only do one draw out of the hat. Okay? Because as soon as you get a green ball, you can stop. It says until a green ball is selected. Maybe I put my hand in and I get the green ball on the first draw. And we're done. Now if it says X is the number of balls selected, well, I could finish after one selection because I got green on the first go, right? And that would be valid. And the probability there, we've got 2 green out of 4 balls total. So there's a probability of a half that that actually happens, okay? However, what would happen if I took a red ball out of the hat? So maybe I have a red ball, I've got to go in again. Maybe I get the green ball on the second draw, right? So that's possible. Let's state possible values of X. I'll just undo that. All right, so possible values of X. X could equal 1. It could equal 2. It could also equal 3. So I could do draw 1. I take a red out. I go back in again because I'm trying to get a green, but I get the other red. Now when I go back in for the third draw, there's no option. I have to get a green because there's only greens left. Okay? So that's what's happening. We need to assign probabilities to the second draw and the third draw, but it's a little bit more complicated, right? The first probability was easy to see. It was 2, there's 2 green out of 4, right? But when we get to a second draw, well, we've already done a first draw, so we need to do a calculation there, right? We need to think, well, there was a 1 in 2 probability, right? So the probability that the variable is 2 for 2 draws, well, there's a half probability that I got a red on the first one, and then there'd be, so that was my first event, then I'd have to multiply that by the probability of getting a green on the second draw, that's 2/3, which makes 2 out of 6, which equals a third, okay? So that probability there is a third. Now it might be worth drawing yourself a little tree diagram for this situation. So I'm not sure if I can fit it on here, but we could have got a red ball on the very first draw. There was a half probability that that could have happened, but we could have gone green first, right? And there was a probability of a half that that would happen. Now, this path of the tree is now terminated, it's finished. If I got a red ball on the first draw, I'd have to go back in again until I got a green, right? Now at this stage, we've got 3 balls left. 2 of the balls left are green. So along this pathway, it would be a half times 2/3, right? So the probability that I had red then green equals 1/2 times 2/3. All right. But let's imagine that we got a red followed by a red. A red followed by a red. Then we'd have to go back in again for a green, right? Now, that last green would be certain because it would be all that was left. So this would just be a probability of 1. But what about getting this second red? All right, there's 3 balls left. Only one of them is red, right? When we get to this point, there's only 2 balls left and they're both green. So it's 2 out of 2. So along this pathway here, where we need to do 3 draws, it'll be red, red, green. It'll be 1/2 times 1/3, which is 1/6. All right. Now, if this is a valid probability distribution, which it is, all right, then all of those probabilities need to add up to equal 1, and they do. So if you did 1/2, right, 1/2 is 3/6 plus 1/3, that's 2/6, plus 1/6, this equals 1, and that's what we're looking for, right? So the sum, right, from the first sample to the nth sample, in this case, the n equals 3. So I mean, I could just write 3 there for this particular sum. Up to 3 would have to be, and if I sum all those probabilities, it needs to equal 1. And it does, and so that's my check for knowing that I've done this correctly. Okay, thank you for watching that one. Oh, one final thing. We've represented, so where it says the probability distribution, we have represented that in this table. Right? The answer to this question is that table, and that is okay. I could have listed it, just made a list, right? I could have drawn a column graph, but I think the best way is to use this table. These probability values, we could have written them slightly differently. We could say, I've written PI. Right. We could say the probability that the variable equals a particular value of x. Okay. So I think that's probably what the book does in the answer section. All right, thank you for watching.